Now we are taking up the topic periodic classification, and before we do that, I want you to know, I want to recall certain facts which we did in a previous unit, so that you should know that why we are studying this classification and where does this concept of classification came, what is the need of studying this classification, right. So just let me recall those things for you, that it will be easy for you. See, we know that matter is made up of atoms, right? It is clear? Yeah. And the atoms are the building blocks of the element. That means atoms unite to form element. So we can say that elements form the basic unit of matter, right? So now the question comes, what kind of elements are there, how many elements are there, where we found those elements. So taking up the thing step by step, I am telling you. So first of all, you should know the definition of the element. Element is made up of atoms, and it is actually a building block of matter. So around 1800, in year 1800, approximately 31 elements were found, right. And with the passage of time, around 1865, this discovery went to 63 elements, and nowadays, at this time, nowadays approximately 132 elements are known, and still the more discoveries are in pipeline. So, and no matter that these elements can be, they are of two types, they can be man-made. This number comprises of man-made elements, that is synthetic elements, and also the naturally occurring elements. But still we have approximately 102. This is the approximate idea I have, that I am sharing it with you, that is 132 elements that are known till date, and still many more elements are prepared in the lab in a day or two. It is, the discoveries are in pipeline. So that means there are so many elements which are found in earth, no matter it is synthetic or it is man-made, but still we have many elements that is being discovered daily, on daily basis. So if we wish to study about the elements, so I think it will be very difficult to study the 132 elements individually, because we cannot, there are so many properties, how they look, how they behave, how they react with hydrogen or oxygen or any kind of material, as you know that there are so many kind of chemical compounds. So how they react towards them and how they look like, what are their physical properties, what are the chemical properties. So if you wish to take them, study those 132 elements individually, it will be a very difficult task. So to make the study easier, we need a classification. We need a classification. Now the question comes, what do you mean by classification? Classification means to make the study systematic, just grouping similar elements together and separating it from dissimilar ones, right. I will repeat, classification means grouping similar elements together and separating the dissimilar elements from each other. Then how it will be useful now? It must be striking in your mind how it will be useful, because then what you can do is, we can just look for the property of the element and we'll get the idea of all those properties, all those elements which resemble that particular element. So we cannot have the you can say the actual idea, but still we can have the appropriate idea accordingly. So that means the classification can be helpful to make the study systematic, to help in correlating the properties of the elements with some fundamental property. We can also know the relation between different elements, that are, do they resemble each other or they are different from each other. So that means the classification is very important. So just repeating a definition for you, what do we mean by classification? It means grouping elements, the similar elements together and separating the dissimilar elements from each other, so that we can have the better idea, we can study the element in a proper manner. All elements we can cover in that case, and it will be easy for us to recall the properties if we classify those elements, because when we will think that it belongs to a certain family, we must be having an idea for that family. So we just have to remember, yeah, it is a member of that family, then all the properties will just, you will recall that. So that means the classification is very important and it will make the study more easier. Now coming to the point how classification was done. So the first attempt for classifying the elements was made by the earlier chemist. However, it failed, but still they made the first attempt. And what was the first attempt? It was the early chemist. We call them as early chemist. So what they do, they just classified the elements on the basis of properties. The basic property that they took into consideration was valency, and the behavior, that means they behave as metal or non-metal. So they classified the elements according to their properties like valency and all into two groups, as metals and non-metals. So the question must be striking your mind that where will be the metalloids go? Because they just classified the elements into metals and non-metals. Like they said, the elements which are hard, which are sonorous, which are lustrous, which are good conductor of heat and electricity, or blah blah blah, they come under the category metal. And the elements which are non-lustrous, non-sonorous, poor conductor of heat and electricity, with 4, 5, 6, 7 valence electrons, or so many properties you know now, they come under the category non-metals. But we do have the elements called as metalloids, which have the properties same as metals and non-metals. So there were no place for the metalloids. So this classification actually failed. Then the second contribution in classifying the elements came from the German chemist called as Daubernier. So the second contribution in classifying the elements came from the scientist Daubernier, who was a German chemist. He made a great effort. However, he didn't succeed in you can say the classifying all the elements, but still he made a little contribution. He was able to correlate certain properties. He was able to you can say prove certain resemblance between the elements. Now how he did, just look at the board. So three things he kept in mind while classifying the elements. First, he classified the elements in order of increasing atomic weights. So that means what property he kept in mind, what fundamental property he kept in mind was the atomic weight. He arranged the elements in order of increasing atomic weight. This was the first criteria he kept in mind while he was classifying the elements. Second, he arranged the elements in group of three, and the name given was the element which belongs to the group of three as triads. The name given was triads. So he arranged, the second criteria was he arranged the elements in group of three elements together, 3 elements were clubbed together in a triad. And third, the elements which were arranged in the triad resemble each other in physical and chemical properties. And there was a resemblance. Obviously, we need to have the elements in a triad which resemble in properties. So they were resembling in physical and chemical properties. And fourth, what criteria he kept in mind was that while he was arranging them, he saw that the middle element, the atomic mass of the middle element was arithmetic mean of the first and the atomic mass of the first and the third element. This will be clear when I'll take an example. So just look for the triads. For example, the first triad he made was lithium, sodium, potassium. It was the first triad. See, this is how you will represent the triad. That means the group of 3 elements. So what was this thing? See, all these criteria will be fulfilled by the triad. Now how it is fulfilled, just look at the board. So he's first I am taking this fourth one. See, the atomic mass for the lithium is 9 and for the potassium it is 39. So the middle element atomic mass was the arithmetic mean of the atomic mass of the first and the third. So that means 9 plus 39 by 2 comes out to be 23. So this was the atomic mass of the sodium. So this is the fourth. I think it is clear now. The atomic mass of the middle element was the arithmetic mean of the atomic mass of the first and the third element. So this justifies this fourth criteria. Then more criteria we will be seeing that whether they obey or not. He made the elements arranged in a group of 3, that is triad. You can see these are 3 elements grouped together, that is, it is a triad. Next, increasing atomic weight. You can easily see the atomic weight is in increasing order, 9, 23, 39. That means atomic weight is increasing. Lastly, they should resemble in physical and chemical properties. We know they resemble in their physical and chemical properties as 3 of them are metals with +1 valency. And moreover, they have many properties similar to as they are grouped in the category of metals. So obviously they resemble each other in many properties. So he named this triad as alkali group triad, as they are member of alkali group. That means when they are dissolved in water, they form strong alkalis. So it was alkali group triad. He made few more triads, as I am illustrating an example for you, that is like iron, cobalt, nickel. See, you have to arrange like this. Similarly, same, increasing atomic mass, similarity in properties, group of 3 triad. The atomic mass of the cobalt is the arithmetic mean of the atomic mass of the iron and the nickel. Similarly, one more example, chlorine, bromine, iodine. It was called as halogen group triad because they are all halogens. Similarly, the same properties, it fulfill all these 4 criteria. Similarly, we have few more example, like it was calcium, strontium, barium. It is called as alkaline group triad because they are alkaline in nature. So like this, he was able to make 4 or 5 triads, but actually this classification, this kind of classification failed because he was not able to make more triads fulfilling all these 4 criteria. Because the 4 criteria, the triad should fulfill the all these 4 criteria, that is increasing atomic weight. They should be arranged in group of 3 triad, they should resemble each other, and the atomic mass of the middle should be arithmetic mean of the atomic mass of the first and the third. So he was able to make fewer triads like this, but he was unable to make more triads because they were not fulfilling all those properties. They might have been fulfilling the 1 or 2 properties, but the other properties were lacking in it. So actually the Daubonnier failed in classifying the elements, but still he made a contribution. That is a big effort, because it is not always that you succeed in the things you do. It is always a good attempt that you at least try. Right, so Daubonnier made that try. Then the second classification, the second attempt who made was a English chemist called as Newland. So let's see what he did, what contribution he did. So the second, you can say, the classification was done by Alexander Newland. Now, we should know what criteria he kept in classifying the elements. As we know that the Daubonnier kept the 4 criteria, so we should look at what criteria Alexander Newland kept in mind while classifying the elements. He classified actually the elements on the musical note. His classification was entirely different, you can say, because he classified the elements on the basis of musical note. As you must have heard about the musical notes components, that is sa, re, ga, ma, pa, dha, ni, sa. So similarly, he made the contribution, he made an attempt to classify the elements on the basis of that musical note. So the criteria he used was, first, again increasing atomic weight. So that means the fundamental property he also used was the same as used by the Daubonnier, that is the atomic weight, and that is in the increasing order. And secondly, what he did while he was arranging the elements in order of musical note, like, see, I am writing it for you how he arranged. He arranged like this: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Noble gases were actually missing in it, and so more lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Argon was again missing. We write potassium and calcium. He was able to classify the elements only till Ca, calcium, that is with atomic mass 40 mu. So what he said, so see, we'll see that do they obey the criteria the Alexander Newland used. So the first criteria was the arrangement in order of increasing atomic weights. We can see, if you write the masses, you will get to see that the atomic mass, atomic weights are is in increasing order. The secondly, the second thing what he wrote, what he told is that how he resembled the musical note. As we know, if we start from sa, sa is the first musical note, sa, re, ga, ma, pa, dha, ni, sa. That means first sa comes at first note and the last sa comes at 8th note. So similarly he said that means sa and sa both are similar. So similarly he applied that condition to this here. He said that every 8th element resemble its first element in properties. Like if I want to look for sodium, that to whom element the sodium resemble, so I'll just count the 8 from that. That is, the sodium is the 8th element. 8 means 8, 7, 6, 5, 4, 3, 2, 1. That means it is similar to the lithium. So that as the Sa is similar to the Sa, the first note is similar to the 8th note. So similarly, we can every 8th element repeat the properties of its first element. Like the silicon repeat the properties of the carbon, aluminium repeat the properties of boron. Similarly, every 8th element shows the properties similar to its first element. So this is how he arranged the elements that way. But at that moment only fewer elements were there. There were not so much elements, but still it was discarded because he was able to arrange those elements, only lighter elements, that is up to atomic mass 40. He was unable to arrange the elements with more atomic mass. So actually this classification failed, but still it was an interesting one because no scientist has relate the chemistry with the music, and he was the one who relate the chemistry with the musical note. So he made an effort, but still it failed because he failed to classify the elements beyond